and Sharoon will, Hanook from FC College will of course I'll share his brief bio with you as well. But right now we are talking about quantitative research. There are 730 non-FCCU registrants, and there were only 173 from FCCU that registered, but only 8 of you responded to the materials that we sent to you for queries and questions. And I think, Sharoon, that those have been shared with you.
Yes.
Have you? Yeah, so you are looking at, I think they are a part of your presentation as well.
Yeah.
What does it mean? What are the tools? How do you determine a sample size? How to begin thinking of data analysis, meta-analysis, and so on. So this must be a part of your presentation. So what I would suggest is that you go on with your presentation, and many questions that have come to us will be covered in that context. Right now, the agenda of for today's talk, as you can see, agenda, please dikha de, Gohar. I am Ruxana from CLT, and Gohar is the manager at our center. And you will see what are different research study designs, how do you plan for them, what are the tools, and how to determine the sample size. The dot on in response to your questions. Please, Gohar, could you do the netiquettes before we proceed further?
Hello, everyone. As ma'am has already explained, can you please rename your Zoom accounts to the name of your university and then your name afterwards? And you're requested to turn off your video so that you do not face any bandwidth issues. And you will be muted throughout the session. And at the end of the session, for the question answers session, we might unmute you, and you can also write down your questions in the Zoom chat and we respond to you. The session will be recorded, and hope you have a great session.
Excellent. So Sharoon, again, at FCCU, we are very lucky to have a whole deal of experts who are exceptional in their field. And Sharoon, may I say, is a PhD in biostatistics, epidemiology and biostatistics from USA University. And I think, if I'm not wrong, at least till some 1 year ago, he was the only one in Pakistan. I wonder if there's another one, a PhD in biostatistics. So you couldn't have got a better person to talk about statistical and quantitative research. He is at a very young age, presently the chairperson of the Department of Statistics at our campus, and he is, since statistics in a liberal arts university does not get the focus that it should, he has actually co-listed his courses with other departments, which is an excellent example of cross-disciplinary collaborations. He is a member of the American Statistical Association. He was a Fulbright Fellow, and he is working on very different committees in different parts of the country. So over to you, Sharoon. I'm delighted to have you with us. Gee.
Thank you so much, Dr. Ruxana. I'm also delighted to be the part of this seminar series. I hope people will enjoy learning from it. I understand this information has already been shared with the people, but obviously, as the time grows, there's more knowledge that we acquire, and there's certainly be a slight difference as what has been talked about it earlier. But before I start, I just want to make sure that is my screen shareable to all of you? Can you view this?
Absolutely.
All?
Yes, yeah, absolutely.
Sure, that's great. So I'll just switch on to the full screen mode. I hope that's visible too.
Yes, please.
Okay. All right.
Yeah, great.
So as Dr. Ruxana just mentioned, that we had a session on qualitative research, and now we are going to talk about the quantitative research. Firstly, just briefly talking about how they're different. Obviously, they are different in a lot of different aspects, but my focus is more towards the planning. That how do you plan a quantitative research. And when you talk about the planning of a qualitative research, you can be very abrupt. You can start and then you spend more time once you're collating the things, when you're summarizing the thing and finding conclusion at the end. That's what we do in qualitative research. But in the quantitative research, it is a lot of labor that need to be done before you actually start doing research. And I'm going to talk about few steps that we want to do. And when you do quantitative research, we actually have a very set format to go through it, that you have to have a research problem. You do the systematic review of the literature, research question, you develop hypotheses out of it, operationalization, data collection, analysis, reporting, presenting and publishing, and policy making. One aspect that is very important, and that's a fundamental to the quantitative research, and I think overall research as well, is the review of the literature. Even prior to starting talking about the research problem, your review of the literature, having sufficient information about the problem is something that's a key. So though I have written systematic review of the literature at step 2, but I personally think, and that's what I always do, that systematic review of the literature is point 0 here, then research problem, systematic review of the literature, research question, systematic review of the literature hypothesis, systematic review of the literature, research design operationalization. I mean, research review of the literature actually goes from the beginning, and that's where we end. So policy making is certainly not the end, but that's going to be a commencement of a new thing. So, systematic review of the literature even goes beyond policy making. And that's when you start looking into the further aspects that your research has guided you, that these are the gaps that your research have identified, and you go to the policy making and then start doing review of the literature and keep going through the process on and on. So one very important thing about the quantitative research, which I have seen most of the time people miss, what they do is they jump onto the step of data collection very fast. Rather, when they start thinking about their research, they say, where should I get the data from? They spend a lot of time on data collection. But I personally think that when you are doing quantitative research, first 5 steps are the key, where you need to spend most time in quantitative research. And all these steps are done prior to data collection. So this is all table work that you actually do. So spending time on having a research problem, spending time on having a review of the literature, spending time on the research questions, spending time on developing hypotheses, spending time on research design. That takes the most of the time in your quantitative research. And in today's talk, I'm going to go through all of them, though this constitutes my whole 3 credit hours lecture, but I'll try to be as precise as I can, and would obviously look forward to your questions at the end, right? So let me start with the research problem. And again, I would emphasize on one thing, that keep this in mind. Data collection should be done at 6th step. Prior to data collection, you have to have the first 5 steps very clearly defined. And more specifically about research design, I have came across a lot of studies in the past where I have seen that, yeah, the studies are pretty good. Research question was really amazing. Research problem was, and hypotheses were like something that will like get you off the chair right away, but they lack at the research design, because this is the step they didn't really think through it. And at the end, what they found is that their data collection was some problematic, their analysis and interpretation, and it leads all the way to the end. One more important thing I would like to highlight is a lot of academic researchers in the academia, they focus on reporting the results and publishing and presenting, but their goal is to publish in the scientific research article. I don't find problem. That's what we do the research for. But you should understand the scientific publications, the scientific research journals are intended for a very limited audience. Not everyone, I do not know how many of you follow just one journal on a regular basis. Hardly one or two maybe, but not many people, right? Right now, subscriptions to the journal is super expensive that you can't really afford reading a same journal and it's every new issue coming up. So the thing is that how can the policymaker who should be using your research into the policy, how they get to know about it? And they get to know about it publishing a news article, because all the policymaker in Pakistan and globally as well, what they look forward to is the newspaper. They look forward to the newspaper every morning. So they really want to see that what the current research is happening in the newspaper. They did not have time. They did not have appropriate understanding of your hardcore scientific knowledge to look into the research thesis or scientific publications. So I always encourage academia that, yes, that's wonderful if you publish it in a scientific article, but once it's published in the scientific journal, start thinking of writing a small summary for a general audience. That could be a common people out there, that how they can be benefited of your research. So when I speak about reporting, presenting, and publishing, that's what I mean here. Not only scientific journals, but also do it for the general audience, where a common man can read about your research, right? So, I mean, yesterday I was reading a news article on BBC that talked about that what new cancer interventions are out there, and that was written for common man. So I would encourage you as a researcher as well, that start thinking of writing newspaper articles where you write letter to editors or something, make it some news so that it can reach to the common audience, common people, and especially the policymakers who are actually going to impact the how the country works. So the first thing I want to talk about is research question. And once you have the research problem, then the second thing you want to focus on in the research question. And then in research question, I often talk about this tool that's called finer criteria. This is something that helps us to formulate a good research question. And F here stands for feasible, I stands for interesting, N for novel, E ethical, and R is about relevant. So, when you are planning your research question, please make sure it's feasible. You have adequate number of subjects out there. You have adequate technical expertise. It is affordable in time and money, and it's manageable in scope. The problem that we often face and this is a real example that I have came across, that, in Pakistan, in our universities, all universities does not have all the resources that are required to carry out a specific task, let's say in biomedical engineering or biomedical sciences. So then, before you starting the research and you're laying out your research question, you should really talk about it. That who would be my respondents? How much subjects do I need to carry out this research? And adequate technical expertise. If I'm doing my research in FC College, I would like to focus on that. Do I have required technology available at FC College to carry out this research? One thing. Second thing, do I have trained people who can help me do this research, or who can troubleshoot with the technology that's required? Or do I have those expertise on this? If you do not have those expertise, I would encourage that stop thinking about it, or think about something else, or change your plan accordingly so that you can do it within your resources, or find out a university that can provide you this facility, which is kind of a tough task. Sometimes other universities have their own restrictions. They have their own resources that are allocated for their own students. So, this is something, feasibility is something that's of very importance, especially not only in Pakistan. I have found the same kind of problems in technologically advanced countries as well. Even in the US, not one university have all the resources. So there are universities who collaborate. So always look for the technical expertise available to carry out your research, then the time and money. This is where a lot of people I have found that they underestimate their time and they underestimate their money. Generally, money may not play a very big role in social sciences research or humanities research, but if you're talking about the natural sciences research, money is one of the very big issue out there. A lot of research is dependent upon money. So always ask your supervisor, do we have enough monetary resources so that we can carry out research? Because if you are doing certain some genetic tasks that requires you to let's say you want to do sequencing of a gene, it requires a lot of money, right? And we have like very few places where it happens. Now the number has grown up, but not everywhere you can do this. So you go to the corporate world where they do it, and they always charge you higher. So always talk about the money, because I have come across a lot of situations where a researcher says that, oh well, we don't have money, so we just ran only 10 samples, and sometimes 10 samples are not sufficient. They are not the adequate number of subjects, and moreover the time. This is kind of a vicious cycle sometimes I have found people getting caught up with, especially when they are doing quantitative research, because they haven't thought of it at the beginning of their study. Hence, they always tend to fall back. So, for the time, you always need to make sure you are doing MPhil research, you are doing PhD research, you have 2-3 years to carry out your research, or 1 year or 2 years. Always keep that in mind, that the project, the questions, the research question I'm going to talk about, will I be able to answer this research question in the adequate time? And then it should be manageable in scope. And I've already shared about it a bit. Interesting, getting the answer intrigues the investigator and her friends. It is not about it intrigues the people out there. No, it should something that excites you as a researcher. If you do not enjoy talking about this research question, better is not take it. Why? Because you will lose interest right away. Because sometimes research is exciting. Most of the time research is exciting, but sometimes it gets boring. It gets very stressful. And when it gets stressful, people try to lose the track. And when this happens, then it's not interesting anymore. So make sure that you're doing research question you're building is interesting. Then it should be novel. It should confirm, refute, or extend previous findings. So I have seen people talking about novelty, and they always talk about, extending previous findings. They want to find new findings. A lot of supervisors I have seen, what they do is, oh, what new have you done? I personally think that in Pakistan, if you are doing the similar analysis, similar research that was done somewhere on the Pakistani population, it should confirm or refute existing theory, which is also a research. And it also talks about the novelty, because I am talking about my research in the Pakistani population, because our dynamics are different, our environment is different, our cultures are different from African countries, or from European countries, or from American countries, right? The one in the North America or South Americas, or some other places, right? So, we should not, say that, oh, my research confirms this existing theory, and that is what novelty is. We should actually think about this instead of saying, oh, well, you haven't done anything else because it has already been done. What's new you have done? That should not be our argument when we talk about the novelty of a research. And ethical, all institutions nowadays, they have institution review board. Please get your research evaluated by the institution review board. That's IRB. Especially when you're doing human subject research, it is highly advised that you please carry out follow the ethical guidelines. And in Pakistan, we have National Bioethics Committee that follows the guidelines of Helsinki Declaration. So that is extremely important. And your research should be relevant to the scientific knowledge and to the future. when you say scientific knowledge, it should fit well into the theory and more relevant today. You really don't want to do research. I mean, so generally we get novelty in some, like if you are following up 1935 research and now you're bringing new innovation into it, that's great if it is relevant for today, if it's required today. Otherwise, developing something on the base of 1935 research today, and you know that it's never going to help anyone, it's never going to be used, it is a futile effort. It's not going to be used anywhere. You won't get citations, you won't get all those kind of, we have indexes. So whenever you talk about your research question, please do talk about the final criteria. Once you have decided about the final criteria, though I have skipped this hypothesis section, but I would really like to highlight the hypothesis, that which is a lot of people really misinterprets. And in terms of hypothesis, when we talk about hypothesis, we talk about always think in terms, what is my expected result from this research question? What will be my expected outcomes? So your expected outcomes should be laid out in hypothesis. And once you have defined out your expected outcomes that are related to your research question into your hypothesis, then you talk about the research design. There is this research article that was published in 2015 that talked about that 85% of the research produced in biomedical sciences was either wrong or it has error. And a lot of research, out of those 85% of research he evaluated, they were weak on the research design, which is kind of the key. So when you talk about this, when you talk about the study design, you want to first you talk about the Picot criteria, or sometimes people call it Picot. Picot is first you talk about the population. And again, I would like to remind you, we are doing all those things before we collect the data. We are not starting with collecting the data first and talking about this thing. You have to spend a rigorous amount of time on talking about hypothesis, question, problem, literature review, and then study design. And while you are talking about your study design, talk about the Picot criteria. In Picot population, you really want to talk about the population, that who are the intended audience I will recruit to collect the sample from. There may be a fine balance between defining a sample that is most likely to respond to your intervention, but you really want to make sure that to what group I'm going to generalize my results, right? And then intervention. Am I using an intervention? Because talking about this intervention is extremely important. That will help us figure out that which study design I should be using. So it refers to the treatment that will be provided to the subject enrolled in your study. Not all studies should have intervention. So if you have intervention, please put it here. If you did not have intervention, no need to write about it, because there are study designs that do not require to have an intervention. Then you want to talk about the comparison group. Most of the time, when we talk about the comparison group, we talk about the control group, but control group or some existing gold standard group. So always, if you have a comparison group that you think of as a baseline for your comparison, do list it out. Because I have seen some researches where people come and they bring their data and they say, oh, well, I want to compare it, that how it works with the normal people. And they have never collected the data from the normal people, right? So it is really important that when you have written your question, you talk about the Picot, and if you have a comparison group, please write this statement down here, that who are going to be your comparison group. Write down a complete description of the comparison group, whether they are control group or they are gold standard. If they are control group, what are the characteristics of the control group? Why you think they are control group? Why you think they are neutral group? Then outcome. Your outcome represent what results you plan on measuring to examine the effectiveness of your intervention. This is something that I have seen some of the researchers miss out. They say, oh, I want to measure that if the males are taller than females, and then taller in height, right? But in none of the question asked for the height. So, how can you respond if you've never measured that? And some of the researchers that are done in social sciences, I have found that they miss out at the outcomes a lot of time because they are using some existing tools sometimes. So always please talk about the outcome that you wanna, you wanna use. Then you talk about the time, that what should be the duration of for your data collection. That's very important to go ahead with. So here are a few study designs I want to talk about: the case report and case series. Then we have observation studies, cross-section studies, case control, cohort, randomized, systematic review, and meta-analysis. I have once you have defined your PICO, then population, you will know who is your population. Intervention, if you have intervention, then are you assigning exposure as a researcher to the respondents? If you are assigning exposure, then you are into the experimental study. If you're not assigning an exposure, you are into an observational studies. Like for example, let's say I'm trying to see the impact of use of softwares into my teaching of my course. And what I do is I firstly teach my students that software. It means I am assigning an exposure where students are exposed to that intervention I want to use. So when they are exposed to the intervention by researcher, and researcher do that, then it is, yes, it's going to be an experimental study. But if you do not assign exposure, but you take some courses where the student have studied with the technology and some students where they have not studied with the technology, and you are going to make the comparison, over there, researcher is not assigning the exposure, and then it will be an observational study where you can have comparison group. The ones, if you have a comparison group, you are into analytical studies. If you do not have a comparison group, you are into descriptive study. Like all the people who have studied in a technology room where with efficient use of technology, all of the people are my part of my study, then it's simply a descriptive study because you're not including any comparison group. But if you have a group of people who have studied in a technological environment, and then you have a comparison group where the people who have not studied in that kind of environment, where the intervention is applied, then you call it analytical study because you have a comparison group along with that. But for the comparison group, we have three methods: then cross-sectional study, case control study, and cohort study. The direction is very important, that when direction between exposure and outcome. If exposure and outcome are measured at the same time, we talk about the cross-sectional study. If exposure and outcome is observed and you look for exposure in the past, then you talk about the case control study. Like in case control study, we can have the group of diabetic people and group of non-diabetic people, and we just ask them. So we have outcome in hand already, diabetes, and we want to find out the risk factors for diabetes. We'll ask them, how many hours do you sit? Do you have diabetes in your gene through your parents or your grandparents? So when you're looking for the exposure in the past, you're talking about the case control study. And the cohort study is where you take the exposure today and then you follow them for the outcome. Like we have the people, let's say, the ones who receive the COVID vaccination. So we get people who receive the COVID vaccine and the people who haven't received the COVID vaccine. So they are already exposed to the COVID vaccination. And then we follow them up into the future to see that how the COVID vaccine helped them fight the disease, or what are the adverse outcomes that may have happened, or you look for the outcomes into the future. In cohort studies, you can have more than one outcomes. In case control study, generally we have one outcome. And in the cross-section study, we also have one outcome. But cohort study, cohort by word, it's group, where you recruit a group, a cohort that are exposed and that are not exposed, and then you follow them up into the future to look for an outcome. Now, the other type of studies are experimental study, where you think of doing a random allocation. A lot of studies that are done in biomedical sciences are experimental studies. In physics and so in sciences generally, they are experimental study, but that's very important here to figure out. And nowadays, actually, I've seen in economics, people have started doing randomized controlled trials, and in sociology as well, in psychology as well. So earlier, those fields were more, talking about cross-sectional case control studies, but nowadays there are people who have started doing experimental studies. So over here, the very first question we ask is, do we have a random allocation? Are we allocating the people to an exposure? If we are assigning the exposure randomly, then you talk about them as a randomized controlled trial. If you're doing no randomization, then you call it non-randomized controlled trial. Non-randomized controlled trial are also called quasi-controlled trial, right? So they're not really quite randomized controlled trial, right? One important thing I would like to highlight here is the strength of evidence goes from right to left. If you do descriptive study, that provides you the weakest evidence. If you do cross-section study, that will provide you a better, stronger evidence as compared to the descriptive study. Case control study provides better evidence than cross-sectional. Cohort study provide better than case control. Non-randomized provide better than cohort study, and randomized control trial provides better evidence, stronger evidence. So one of the strongest evidence that you can get is randomized control trial. On the basis of it, you can develop the causal relationship between the exposure and the outcome. So here is a pyramid that talks about the quality of evidence. Often talk about the expert opinions or some background information. If some expert is talking about it, oh, that's what I believe, then always know this, that the person, when they say they are believing on this thing, that's simply an expert opinion. That's not a scientific evidence. But obviously their belief comes from the scientific evidence for sure, but still, show me with the data, show me with the results. That is the weakest form of evidence that you can get. But once you've done that, you have individual case reports. I hope you might have learned about cases in Pakistan where we have the solar kids who are getting paralyzed when the sun sets, and when as soon as the sun used to rise, they are living their life as a normal kids. Recently, we got to know that those two siblings, they belong to Peshawar. So those are the only cases in Pakistan, or actually in the world, I would think so. So those, if you report the results of those kind of very unique group of people, you talk about the case reports. Like in the case of COVID, the very first researches that we got from China, they talk about, we are looking at the people who are coming into the hospital with unknown pneumonia. When they start talking about unknown pneumonia, so they had pneumonia that was again a lungs, their lungs were getting affected, but they didn't really know that what's causing that disease. So when they found out the very first person, they call it case report. But when more cases start coming in and you start reporting cases, you call it case reports or case series there. So case series, afterwards, they go to the case control studies and cross-sectional studies, but then we have the cohort studies. Cohort studies brings us a stronger evidence. After cohort studies, we have non-randomized control trial and randomized control trial. These are the designs I've already talked about, but then these are the critical appraisals. In critical appraisals, you carry out the evidence-based practice guidelines or systematic reviews and meta-analyses. These are the strongest form of evidence. But the thing is, in meta-analysis and systematic review, we make use of the existing literature. We use the randomized control trial to carry out the meta-analysis. We carry out non-randomized control trials to carry out the meta-analysis or systematic review. So though they present us a stronger evidence, but they are based upon the studies which are replicated at different places. Like we carried out this study in Pakistan where we tried to look at the effect, how how this malarial drug really helped cure COVID. And we got to know that there are 200 studies which were being done in 2020 all over the world to see the effect of that specific drug. That is, probably you know the name, hydroxychloroquine, right? That was pretty much discussed by the Donald Trump as well. So we had like 200 something studies that were being done all over the world at that time. What we done is some of the researchers have done, they've pulled out the results from all the studies and then gave the meta-analysis. So meta-analysis and systematic reviews are done on the existing studies, that those be randomized control trial, non-randomized control trial, cohort, or whatever type of studies they are. But these are not like the studies which are actually performed by doing them into the population, but these are the studies which we do using the existing literature that has already been published. So, but they provide us the strongest evidence in science that we get, and whenever we talk about the quantitative research. So now the question is how to spot the study design. That is extremely important. The very first question that you should ask is, what was the aim of the study? And if your aim is to simply describe a population, you would be answering in Picot, you would have answered population and outcome. You did not talk about the intervention. You did not talk about the comparison. If that's the case, you are talking about some descriptive study. But if you have responded to all 4 questions, Picot, population, intervention, comparison, and outcome, then it means you want to quantify the relationship between factors, then you are into the arena of analytical study. But in analytical study, the second question you ask is, was the intervention randomly allocated? If yes, you talk about randomized control trial. If no, then talk about the observational study. And it's not about here with intervention, I mean exposure. Then what the outcomes determined, that's the third question you need to ask. If they are non-randomized, if they're randomized, you stop here. But if they're observational, then you ask a third question. When were the outcomes determined? If the outcomes determined sometimes after the exposure of the intervention, after the exposure means cohort study, that's prospective. Prospective means some study that goes into the future. At the same time as exposure or intervention, when outcome and exposure are studied at the same time, we talk about the cross-sectional studies. And when outcome is determined before the exposure, then you talk about the case control study. And case control studies are retrospective studies which are based upon a lot of recall of the exposure in the history. So I would talk a bit about some advantages and disadvantages. So an experimental study in which participants are allocated to treatment or control, placebo group using a random mechanism, we call them randomized control trial. Randomized control trial are unbiased distribution of confounders. Their blinding is more likely, and randomization facilitates statistical analysis. And these are the study designs where we can establish causal relationship, where we can exactly tell that what is the cause of what effect out there. But it does have disadvantages. It's expensive because you need a very controlled environment, and it requires a lot of time and money to establish that kind of controlled environment. There's always a volunteer bias, and they're sometimes ethically problematic at times. Then in the cohort studies, data are obtained from groups we have been exposed or they are not exposed, and no allocation of exposure is made by the researcher, whereas in the randomized trials, exposure is made by the researcher. But best for study the effect of predictive risk factor of an outcome, and the advantages include they're ethically safe. One of the longest cohort study is called the happiness study, or there is twins study that is running for I think almost 80 years now, where they have recruited twins when they were born, and they are following them even today. They've been following them. They are ethically safe. Subjects can be matched, like in the twins study, they have a matched subject where they are a lot of genetically, they are similar to each other, or their historical backgrounds are same. And they can establish timing and directionality of the event, that you look things into the future, and eligibility criteria and outcomes can be standardized. That's very important there as well in the cohort study. And they are administratively easier and cheaper than RCT, but still they are expensive. So that's what their disadvantage is as well, that controls may be difficult to identify because you can't really talk about who are not exposed there, because you're not assigning exposure by yourself. And exposure may be linked to hidden confounders, and blinding is difficult. You can't really blind things. So blinding is one of the very important concepts when you talk about randomized trials. Double-blinded randomized trials are considered to be very effective as compared to unblinded randomized trials. So blinding is when a researcher doesn't know what intervention has been used, or the person who is implying that intervention doesn't really know that what intervention is being used. Or respondent doesn't know that if that's the only intervention, or there is some other comparative intervention out there, or sometimes people are assigned placebo there. So randomization not present. Randomization is a very wonderful concept that gives us a lot of confidence when you carry out the statistical analysis. And for rare disease, large sample sizes or long follow-up, you can't really use them. In case control study, participants are selected with a certain outcome and appropriate group of controls without the outcome, and some are those are called controls, and the ones that have the outcome, they're called cases. So they're quick and cheap, they're feasible for very rare disorders, and there are fewer subjects needed than cross-sectional studies, but certainly for cohort studies, larger subjects needed as compared to cohort studies. So their disadvantages includes that there's a lot of reliance on recall. So people tend to forget what really is there. Confounders are sometimes not easy to find in case control studies. And selection of control groups is difficult, and potential bias, that is recall and selection bias, can come in. So the other type of studies are cross-section studies that examines the relationship between the exposure and outcome of interest as they exist in defined population, and then best for quantifying the prevalence of exposure. So they're cheap, simple, ethically safe, but they require a very large sample size. They could be, confounders can be defined clearly. There's a recall bias, and one cannot really establish causality with that. Yes, they can do association, but not causality. Now, one of the very important fact that we want to know about is that how much population size do we need? How much sample size do we need? So when we talk about the sample size, and this is something, again, that should be determined prior to your data collection. You cannot do this after your data is collected. We do this, we call this post hoc sample size determination, but it is not highly encouraged to go for the post hoc sample size determination. Always better to determine the sample size prior than starting the study. So when you talk about the population size, you got to talk about that how many total people fit your demographic, and do not worry if you are unsure about the number. It is just it is common for the population to be unknown, or you can always approximate it. The second important thing we want to know is margin of error. That is also, you can think of it as confidence interval. So no sample will be perfect. That's very important to know. So you need to decide how much error you want to allow. So the confidence interval determines how much higher or lower than the population mean you're willing to let your sample mean fall. Let's say I'm interested in looking at the difference between two interventions, and I say, oh, well, if it moves 5 points above and 5 points below that mean, I'm still okay with that. That will determine that you're looking at 5% margin of error over there. So that's something very important. And generally, what I've seen is people keep margin of error to be 5%. So the confidence level, how confident do you want to be that the actual mean falls within your confidence interval? You want to be more confident, you need bigger sample size. You want to be less confident, you will need smaller sample size. I have often seen people talking about this, that, oh, well, sample size of 25% of the population is good. No, there is no magic number like this out there. If someone asks me what's the best sample size, I would say capital N-1. That's just one less than your population size. That is the best sample. And what's the minimum sample? that is 2. But is 2 the best sample? No. Is n minus 1 possible always? No, it's not possible. So we always have a trade-off that, okay, I would simply go with 99% confident or 95% confident. Generally, people keep it 95% confident. Standard deviation, how much variation you want and in your results. So you talk about the standard deviation. So few things that you really need to talk about it before you talk about the method you want to use to determine your sample size. Is the outcome qualitative or categorical? If it is quantitative, you have a different method. If it's categorical, you have different methods. I'm going to talk about the quantitative, the method for the quantitative and continuous both today. So is the outcome a continuous variable? Continuous variable will always be for the quantitative. For categorical, you will just stop and jump on to the 4th point. But for the quantitative variable, you talk about the continuous variable, and do you want to compare the averages? Because you really need to know that what statistical analysis you want to perform prior to determining your sample. Because if you do not know that, oh, if I want to use the averages in my for my quantitative variable and that is continuous, then you should use a specific formula that is done for quantitative, continuous, and averages. But for categorical variable, you do not use average. You actually use percentages and proportions. So that's something that you really need to make sure. Do you want to observe the relationship? If you want to observe the relationship, then you need to talk about that if you want to observe the relationship between categorical variables or quantitative variables. If you're doing it for quantitative variables, we have different methods. If you were doing it for the categorical variable, we have different methods. And the method, the statistical method that you want to define to answer these questions, that will help you determine that what statistical method you want to use to calculate the sample size. Here, I'm talking about the sample size determination for a quantitative continuous variable, where I'm interested in looking at the difference in the means. And when I'm looking at the difference in the mean, then I want to calculate the sample size, which is denoted by small n. And 2 sigma square. Sigma square is a standard deviation of the outcome variable, that how much variation you can have in the outcome variable. So how come you know that variation in the outcome variable? This information we carry out from the previous analyses, previous similar type of studies that have done on the similar population. If there's no existing study available, we carry out a pilot survey. That pilot survey gives us the standard deviation value, that how much variation is there in our outcome variable. Then these are some core typical statistical measures. We call them Z beta and Z alpha by 2 that represent the desired power. Typically you want to have, generally people keep it 80% power. So we calculate the value of it. Then this is how much, what's the level of statistical significance you want to keep it. And generally we keep it 5%. So at 5%, the Z alpha by 2 value is 1.96. And for 80% power, it is, I think, 0.84. So difference is the effect size. How much difference you can afford from your original value. Let's say if my mean is 20, I'm okay if my mean goes from 18 to 22, right? So it means my effect size will be 20 minus 18. That is 2 points. So you take the difference of this and square it up. So here's another example where you set a ratio. Generally, we keep the ratio of sample size to be equal. If we have 2 groups, then we keep R is equals to 1. But if we have, we want to change the ratio, you put the ratio here. But this is sample size, this is variance, Z power, Z alpha by 2, and difference. Just another formula to calculate the sample size when you want to determine you have different ratios of your data. So here's an example. How many people would you need to sample in each group to achieve power of 80% correspond to Z beta, that is 0.85. So I'll put the values. It is 2. 2 is by default in the formula. Sigma square is a variance. So the variation in my outcome is 2. Z beta is 0.84. Z alpha by 2, that is 5% confidence interval, or 95% confidence interval, or the 5% level of significance. The value we get is 1.96. You simply square it up and divide it by the margin of error. I'm okay with 3 points up and down in my results. So that's what margin of error is. And we call it effect size as well. that is square of it. You solve this example, your sample size will be 174. So it means for group 1, you need 174 individuals to be 80% sure, having 5% margin of error, and 3% margin of error, 95% confidence. And altogether, we calculate 348 people. You simply multiply 174 by 2, and you get the total number if you're comparing 2 groups here. Then if you have a categorical variable, then you look for the proportions. And for proportions, we calculate P bar, 1 minus P bar, Z beta, Z alpha are the same. P1 minus P2 is the difference between the two populations. That's what we call effect size. Rest of the things are same. Simply P bar is the proportion in the group of our interest, and 1 minus P bar is the proportion of the people who are not in our interest group. We calculate this, use the same method if you want to use a different ratio, different size of the groups, right? So then we jump, once you have determined our sample size, we go to the data collection, and it is one of the very important aspect of it. Then in your research, quantitative research study, because if your data is incorrect, it will lead to the invalid results, and your results are non-generalizable. And it's mostly done for the primary data. The primary data is the first-hand information that is directly collected by the researcher from the respondent, and it's originated by the researcher, especially to address the research problem. It's costly, time-consuming, but it is more flexible. Otherwise, we can use the secondary data. Like there are a lot of databases out there. You can use the secondary data. If you are doing the secondary data, you generally do not need to develop your own questionnaire. But for the primary data, we generally do develop a questionnaire, right? So here are a few methods. You can do clinical trials, you can do experiment, you can observe and recording well-defined events where you can make direct personal investigation by doing the interview, face-to-face interview, telephonic interview, or computer-assisted person interview, or you develop a questionnaire where you can have paper, pencil questionnaire or web-based questionnaire. A questionnaire, there are a few things that you need to talk about. The first thing is what information should be sought, decide what type of questionnaire should be used. Do you need e-questionnaire? Or do you need paper pen questionnaire? Do you want to develop your questionnaire on what platform? That how do you draft a questionnaire and all those things? And the very first step is that write a first draft of questionnaire. People always draft a questionnaire and think that's the final. No, that's not the best idea. Always have a first draft of questionnaire, re-examine and revise a questionnaire. That's where you can always talk with your research supervisor to re-evaluate it. And you can always do some pre-testing. That's called pilot testing of your questionnaire as well. And while you're doing pilot testing, you can always ask your respondent, how do you understand my question? So that you can understand that the type of question you're asking, with the intention you're asking, your respondents are also understanding that with the same intention for you. So pre-testing is one of the very important key there that actually help us to test our questionnaire's validity as well. So you can also do content validity here when you are re-examining and revising a questionnaire. So you can do content validity here in the pre-testing as well. And then once you've done that, you take expert opinion from your researcher, you take opinion from your prospective respondents, and letting them fill the questionnaire and asking their feedback about the questionnaire, and then edit a question and then go for the sampling strategy. Here are a few questions that you need to understand. That is a question, while you develop a questionnaire, is the question necessary or is it useful? You talk about it. Do you need the age of child or just the number of children under 16? Do you need to ask income or you can estimate it? You can always ask, this is a question where most of the people do not like to respond it. For the older people, they try to overestimate their age. For younger people, they try to underestimate their age. So it's very important that how do you ask a question? I personally generally recommend in the quantitative research, simply ask a very direct question. How old are you? Do not always give the brackets that, oh, is your age 10 to 20, 20 to 30? Do not always make these kind of intervals. Simply ask direct question and encourage your respondent, develop such a rapport with your respondent so that the respondent can give you the exact answer to your question. And nowadays people are very comfortable talking about their age. Yes, not for income, But for income, you can estimate sometimes, but you can still use interval questions for that. So then the second thing you also want to ask is, are questions needed? So several questions needed. So sometimes people ask double-barreled questions. Double-barreled questions are where you talk about the two different aspects, two different groups in the same question. Are you happy with the performance of grooming of your kid? Right? Teacher and parents are two different groups. So ask about the teacher separately and ask about the parents separately. Or sometimes our question doesn't cover all possibilities. So always do not forget to put other and leave a blank next to it in your question, so that if there is any other possibility, people can tick other and write down that what other possibilities are out there. Does not give enough context. Sometimes you don't really talk about it. Like I have given you example here that you should ask a filter question first. Have you ever watched the show Games of Thrones before asking them if they like Jon Snow? Because if you ask me, do you like Jon Snow? I would simply think of an epidemiologist who helped counter the cholera in London back in 1880s, right? So the Jon Snow. If you tell them the context that, oh, I'm going to talk about the Jon Snow in the Game of Thrones, that's specifically your respondent will give you an exact response to your question. Will respondent answer truthfully? That is something that's very critical. So one thing is important. Have you ever had extramarital affair? A lot of people, they lie about it. So how to ask this question? You have to really think about it. So your question types, they could be categorical, multiple choices or check boxes. You can have ordinal questions like drop down or ranking, and interval ratio questions like ranking scales. But you also need to understand how do you translate them. But one important thing is use simple and direct language. Be specific and break down a bigger idea into the multiple question, but do not ask too many questions, because if you ask too many questions, people will not respond to your question. They will see, oh, that's such a heavy questionnaire. They will either they will just click, or they would simply skip the whole thing and say, oh, I'm sorry, I don't have time to this. So be very specific about your questions and avoid leading question. Do not ask people, do you think schools should cut down the gym budget to pay for the crossing guards? Obviously, there's moral thing out there. So people, for these kind of question, people will always say, oh, yes, well, go for morality. They will say, yes. So your responses will be biased. And use more interval question, but not always. Break the survey into multiple pages when you are doing e-questionnaire. Show progress bar. That is always comforting, especially to me as well, that I would know that how much I have to spend time on it, and I would take more interest into it. And make sure survey works on multiple devices. I would skip this slide and will jump on to the validating a questionnaire due to the shortage of time. When you're validating a questionnaire, the very first step is establish face validity. In face validity, you will ask an expert to read your questionnaire. That expert could be your research supervisor or someone who is having a very good knowledge about your field, or ask a psychometrician to check your survey for common errors like double-barreled question, confusing or leading questions. Then step 2 is carry out the pilot survey. You clean your data set and run the principal component analysis. I have just given only one way. That is the quickest way you can do. But there are a lot of other methods to check for the validity of the questionnaire, because validity is of different type: face validity, content validity, and reliability as well. So you really want to make sure that you follow some steps, at least a minimum steps I have talked about here, to make sure that you are doing it well. And once you've done that, check for internal consistency of the questionnaire. That's also talk about the reliability of a questionnaire. And to do this, we carry out a statistical method that's called Cronbach alpha. And that's mostly done for social sciences research, where you're looking at the human behavior. That's where Cronbach alpha is one of the very important measure, where if your Cronbach alpha's value is more than 0.9, it means you have an excellent questionnaire. If it is from 0.8 to 0.9, it's a good questionnaire. From 0.7 to 0.8, it's acceptable. Otherwise, 0.6 to 0.7, questionable. But if it's below that, you better, below than 0.7, it means you really want to revisit your questionnaire. There are flaws in your questionnaire. And step 3, revise if needed. So far, you have not gone to the collection of your data. You have only done all the important necessary things that you think through before you start the quantitative research. As I stated earlier, when you carry out a quantitative research, you spend a huge amount of time in the planning of your quantitative research. And today's talk really focused on, mainly focused on that what ingredients do you need when you are planning your quantitative study. That's all from my side. Thanks. If you have questions, I would love to respond to those.
Yeah, we have, thank you, Sharoon. While you have been talking, we have had lots of superlatives about the talk and how well you have explained and how methodologically you have gone. There's been method to this whole putting it together. You said it's a 3-credit-hour course, but you really did a great job. And I know lots of people who are joined this session, they might know quite a few steps that you cited along the way. We do have questions. They have Muhammad Usman asked about rational, which I responded. Sadia talked about randomized controlled samples. I responded to that. But there's one long question by Ehtisham that, do you feel the scientific journals are gearing up for research to specific dimensions by their selection criteria? And how do you prioritize the scientific publications that give them more citations? Is that what's happening in research? You did say that that makes a difference. Is that what you were trying?
I think we will be talking about this problem in one of our talk that's coming up, where Dr. Sklan and myself and you will be talking about that what books don't teach. We will certainly talking about this thing. But yes, this is a problem out there in publication, that research is sometimes it's really hard to publish, and some journals really look for specific areas out there that we will publish this kind of research. And especially from the third world country, we always find this problem that I do not know, but sometimes I personally feel that our papers are screened out due to it. That's just my personal observation. I may be wrong, but that's what I feel too.
Well, nobody is going to agree to this, but I think there are subtle and hidden factors sometimes that impact various journals. We leave it at that, but there are some other. Cohort, could you start the polling while we take other questions? There was another question, let me see, about systematic literature review. And I think you did explain it, but would you quickly go through it? Because there were 2 questions about it.
All right. For systematic literature review, I would encourage people to check out Cochrane Systematic Review, C-O-C-H-R-A-N-E, Cochrane. That is a collection of a lot of systematic reviews, and they actually carry out over there. They have talked about, there's a website for it, there's a mobile app for it as well. And they talk about that how to carry out the systematic literature review. In systematic literature review, what we do is we firstly define our study question. And with the study question, we talk about that what kind of screening criteria we will use to select a publication that falls under our domain, right? So we clearly specify there that, okay, I need research that was published in the countries which are similar to Pakistan economically, right? Then I want to look for the studies which are talking about the sample size, a cross-sectional study. We specify that what study design is acceptable for our systematic review, right? You cannot just put all type of studies in one systematic review. you carry out systematic review on all case control studies, systematic review on all the cohort studies, systematic review on all the randomized control trials. So you have to define which study design you're going to include into your systematic review. And then you read those articles, you evaluate, you take up their results, and then there are some statistical methods which we carry out to like forest plots are out there. We draw the forest plot, and then using those, we carry out, we find out the individual estimates. From those individual estimates, we obtain global estimates, and that global estimate is generalizable to the overall population, that is across the borders as well. So that's what systematic review and meta-analyses do.
Okay. What do you say about two-way cluster analysis? Madiha Afzal wants to know.
Two-way cluster analysis. I think I need more clarity on the question.
Yeah, Madiha, would you care to explain?
Yes, hi everyone. I just want to ask about two-step cluster analysis. So this is one of the exploratory data analysis techniques in SPSS. If you can tell me something about more about it.
May I request, Madiha, that we will have a session on SPSS? Could you keep that question for that session? If it's a very specific area, then I would recommend that we leave it at that, right?
Yes. Okay. Thank you so much.
Then there is, let me see, there are lots of compliments, Sharoon. I haven't seen those in a long time in the sessions.
Thank you. I greatly appreciate it.
I think, yes, UAT Zunaira, you talked about sampling techniques and random sample, but I think that was covered very comprehensively. I wonder if that was before it was covered. I think there was a very clear, again, Madiha says two-way cluster analysis, but like we will say it, it was so good that I would like to take the lecture again. That was, something. Please share. We will share the presentation recording. And I don't see any other questions, do I? Very fine learning session. Can we develop our own questionnaire at MPhil level? Everybody develops their own questionnaire.
Yeah. I think you should. I would never, I do know that here our students do this. Recently, I've been the part of IRB at FC College, and I have seen our MS students in psychology. They are developing questionnaires. They are actually developing new tools in their MS, in their MPhil research. I don't mind, and I would encourage people. I mean, you just need to follow the proper guidelines to do this. You just don't develop a questionnaire and do not validate it. That's not a good idea. You should go for the proper validation of the questionnaire by using appropriate methodologies that you should do. But I would encourage that.
Yeah, and you've cited those ways in which you can validate and make sure that your questionnaire is credible and validated. At some point, you talked about alpha 2 in a formula. When the time came for the formula, which you explained very well, since I'm very poor at that field, my mind went off. So I didn't. So you used an alpha 2, oblique 2 in some formula.
Yeah.
Could you please explain that?
Yeah, so that's a very typical statistical concept where we talk about alpha is considered to be as the level of significance. It is in probability terms that how much error, how much chance of error I can afford into my decision-making process, because the whole quantitative research leads to the evidence-based policy making and evidence-based decision-making, right? So when you're doing evidence-based decision-making, then you can't always be 100% accurate. You can always have certain amount of error that you can afford. And you say, there is this concept that came from Sir Ronald Almer Fisher in 1935 in his book. He has written it, and that's like one of the most quoted tool that people use always, that they call it level of significance. He said that if it is 1 out of 20, I would take it. So 1 out of 20 is actually 0.05, 5%. So since then, people have been using the 5% level of significance, and they are they're doing it. So level of significance here is 0.05. So alpha is 0.05. You divide it by 2 because there is a possibility of going above or going below. So that's what I meant by Z alpha by 2. So we calculate in probabilistic terms that how much error we can afford there.
I don't know in statistics level of significance.
Sorry, I cannot hear you, Dr. Ruxana. It got stuck.
Can you hear me now?
Yes.
Okay, my internet is unstable. I'm sorry. I should put the video off, I think. There was another, Anila has commented on level of significance to check the error the probability. I think she's responding to the same question, right?
Yes.
Yeah. We don't seem to have any other queries. And thank you so much. Not all of you have polled. I would have wanted us all. There were at a point more than 140 of you. And we're very thankful for your participation that has stayed unwavered. We have 106 now. And we see a lot of compliments, and we are very happy that you have enjoyed the session with us. And like I said, Sharoon is one of our stars at FCC, and there's another session by him. So you will really enjoy that one too. So do join us again. And thank you so much. Thank you, Sharoon.
Thank you so much, Dr. Ruxana, for this opportunity. Take care, everyone. Bye-bye.
Thank you. Bye-bye.